Which brings us to formulas of ionic compounds. Now that we've learned how to name and write formulas for the ions themselves, we can do the compounds. So an ionic compound contains positive and negative ions. A formula unit is the simplest representative particle in an ionic compound. An ionic compound does not have molecules. It's just a series of positive and negative ions, and they are all attracted to each other in all directions. And so we don't really talk about a molecule. So the formula unit, we're looking at the smallest ratio, smallest whole number ratio of the positive ions to the negative ions. The formula unit is neutral in charge. That means that the positive charges and the negative charges have to add up to 0. And what we do to write the formula is we use subscripts to tell us how many of each ion are in the formula unit. The subscripts need to be the smallest ratio. So if you had something like, double oops, there we go. That's where I want it to be. If you've got sodium and chloride, when you put those together, the formula unit is going to be NaCl. We would not write Na2Cl2. This would be neutral. The charges add up to 0, but it's not the lowest ratio. This one is 1 to 1, this one is 2 to 2. And just like with fractions, you know, your math teacher probably didn't like you writing fractions like 2 over 2. Or 2 over 4. They say, reduce the fraction. 2 over 4 is the same as 1 over 2. 2 over 2 is the same as 1 over 1. So we're going for lowest ratio, smallest ratio. So let's do some examples. We're going to write the formula for these compounds. I'm giving you the name, and I'm also giving you the ions with their charges, because right now we're just learning how to put the two ions together. So here's copper 1 oxide. Copper 1 is the name of this ion, and oxide is the name of that ion. And what we're going to do is we're going to look at the charges. This is +1, and this is -2. If we have one of each, are their charges going to add up to 0? No, they won't. Now there's many ways to think about how to do a problem like this. So I'm going to show you a couple of different ways. If you're good with math, you can probably just look at that and think about a least common multiple and figure out that, oh, well, this is a 1 and that's a 2. If I multiply this by 2, I'll get 2, and then they'll be good. So that works for some people. And so you would end up with Cu2O as your formula. That doesn't work for a lot of beginning students. So I'm going to show you the picture method. Write the formulas with their charges, leave a little space, and then I'm going to add up the total positive and negative charges. In one copper 1 ion, what's the total positive charge? It's not a trick question. It's just +1, right? And O2 minus, the charge is -2, right? And those don't add up to 0. We need more positive charges, right? We need this to be a +2, so +2 and -2 add up to 0. We're going for the same number, just a different sign. Well, I can't change the charges. That's what those ions do. I can't change them. But I could add more of them. So if I added another copper ion, now how much positive charge do I have? +2. Now I've got +2 and -2, and so that's going to add up to 0. So I'm going to look at what I've drawn up here. I've got 2 coppers, and so I'm going to write Cu2. The subscript goes after the ion. And notice I'm not writing any charges in here. I'm just writing the element symbols. So I've got 2 of those, and I have 1 of these. So I write O. Chemists don't like to write the number 1. I'm not going to write a 1 down here, because we just don't do that. But that means that there's 1. So that's one way to think about it. Another way to think about it. the crisscross method. This is probably the favorite of most students. Only use the crisscross method when you've looked at these and realized that their charges are not the same. So the charge on this one is an unwritten 1. That's going to be the subscript for the other ion. This is a 2, and that's going to become the subscript for this ion. So this is Cu2O with an unwritten 1. And that's what I call crisscross. Any questions? So let's do a couple more examples. Let's look at cadmium oxide. Cadmium is a transition metal, but it's one of those 3 that we're supposed to figure the charge out on. It doesn't have a Roman numeral. Cadmium's always +2. And then there's oxide. And so when we're writing a formula between these 2 ions, we look at the charges. We've got +2 and we've got -2. All we have to do is shove them together, and their charges will add up to 0. So we just write CDO, and we're done. We don't want to do the crisscross thing because that would give us CD2O2, and that's not the lowest ratio. The crisscross thing does not always work. It works most of the time, which is pretty good. I'd say probably 90–95% of the time the crisscross thing will work just fine. But every once in a while, it'll mess you up. So let's do this third one here. Cobalt-3 oxide. Remember, the Roman numeral tells us the charge. So this is CO3+ and O2-. So let's do all 3 methods. Which one do you want to try first? Crisscross. Okay, we'll do crisscross first. So I'm going to take this 3, and that's going to become the subscript for the oxygen, and the 2 is going to become the subscript for the cadmium. So, I'm sorry, it's not cadmium, it's cobalt. So there's cobalt, and here's oxygen. I'm going to put a 3 here and a 2 there. You have to be careful with your capital letters and your lowercase letters. Cobalt is capital C, lowercase o. Oxygen is a capital O. If you get capital C, capital O, that's carbon monoxide, and that's something entirely different. So size matters when we're writing the symbols for elements. So you like that method? That works, huh? Let's do the picture method. Because that one ends up being fun for this one. Let's do, I'm feeling green right now. So we'll do not copper. Cobalt, 3+, and oxygen, 2-, and then down here I'm just going to add up how many positive and negative charges I've got. From that cobalt 3+ ion, I've got a +3, and from the oxygen, I've got -2. And I look at those, and those do not add up to 0. This one's too small. So I need another oxygen. I can't change the charges. So now I've got -2 and -2, and that adds up to -4. Now I've got too many negative charges. I can't have half of an ion, though. The only thing I can do is add more positives. So I could put another cobalt over there. And now I've got +6. This is what used to happen with my Grandma Johnson. She would eat bread and with it. That was, dinner rolls and strawberry jam. And she'd take a roll and she'd take some jam and she'd eat the roll and there'd be jam left. And so then she'd have to take another roll, but there wasn't quite enough jam for the whole roll, so then she'd have to take more jam. And she could go back and forth all through dinner, eating bread and with it. And that's what it feels like we're doing here, because now we've got too many positive charges. And we feel like we're going in circles and we're never going to get anywhere. Just keep going. It'll stop eventually. So now we need more negatives. So we put in another oxide ion. And phew, now we've got +6 and -6. And those will add up to 0. So we look at what we've drawn. We've drawn 2 cobalt ions. So CO2. And we drew 3 oxide ions, so O3. And we came up with the same formula. And you can do the same thing if math makes a lot of sense to you. You can look at this and say, well, this is 3 minus, and this is minus 2. The least common multiple is 6. So I need to multiply the 3 by 2. I'll have CO2. I need to multiply the 2 by 3, and I'll get O3. And it's okay if that last part didn't make any sense to you. Either do crisscross or draw the pictures. Okay, any questions? This is a very, very important concept of how to put ions together. It's really, really important. There's some things in this class that are not super important. This is one that's really important to understand how these go together.
Last time you said that they had to be neutral, but that has an overall bond negative charge.
Which one?
Cobalt oxide.
This one? No, this is overall neutral charge. Because there's 2 cobalts, so 2 cobalts with 3 plus, it's a total of a +6 charge. And we have 3 oxygens, they each have a 2 minus charge, and so that gives us a -6 charge. +6 and -6 adds up to 0. Where?
Because you circled over the plus.
Oh. Any other questions? Those were monoatomic ions. We also need to be able to write formulas for compounds that contain polyatomic ions. And this follows much the same pattern. The important difference is if we have more than one polyatomic ion, then we need to use parentheses. The example here is ammonium sulfate. NH4 is in parentheses with the 2 on the outside. And then we've got this other polyatomic ion, sulfate. So let's look at those. So ammonium, writing with the eraser, that just never works. Ammonium is NH4 plus. Sulfate is SO4, 2 minus. If we're going to make a compound out of these, the charges have to add up to 0, and so we need 2 of the ammonium ions to balance the charge on 1 sulfate ion. Okay. Now, when we write the formula, we're going to have 2 NH4s. Well, if we do it like this, NH4 with a subscript 2, SO4, that looks like 1 nitrogen and 42 hydrogens. Is that what we meant? No. It gets confusing. And, we could, maybe we could leave a space there. NH4, 2, SO4. But that's a little weird also. So what we have decided to do is we're going to put parentheses around the polyatomic ion, put the subscript on the outside so the numbers don't get all jumbled up together. So in the parentheses is the polyatomic ions formula with all of its associated numbers, and then the number on the outside tells us how many of that package we have. This is a little bit like, buying something at Costco, right? Most of the time you can't just buy one. They come all packaged together. It's a bundle pack, right, with shrink wrap or plastic around it. The parentheses here are like the shrink wrap. And you can't just get 1 nitrogen. You couldn't just get 2 hydrogens. You have to get the 1 nitrogen with the 4 hydrogens all together. It's a package deal. It's a bundle pack. And so we put the shrink wrap around it, and then on the outside, we're saying how many of those packages do we need? We need 2 of them. We only use the parentheses, though, if there's more than 1, because we don't like to write extra stuff. This is a polyatomic ion, isn't it? SO4. But we only have 1 of them, so we're not going to put parentheses around it. So would we understand what you meant if you put parentheses around that? Yeah, but it would look silly. And if I was grading someone's work, I would take my red pen and I would just scribble out the parentheses, because that's just kind of silly. It's like baby chemistry talk. And we're trying to learn grown-up chemistry talk, right? Any other questions? And also don't use parentheses for monoatomic ions. So, like if you have CaCl2, there's no parentheses in that, because we don't need them. We're only writing things that we need to be clear. We're trying to be concise and brief, and yet still have everybody understand what we're talking about. So write the chemical formulas for these compounds. Copper 2 permanganate, and here are the ion formulas. So how many of each ion do we need? We need 2 of the permanganates, because it's got a minus 1 charge. We're going to need 2 of these and 1 of those. So if we have 2 MnO4 minuses, that's going to give us a -2 to the +2 on the copper. You could also do the crisscross thing, and this 2 becomes the subscript on that one, the unwritten 1 becomes the subscript on the other. And so when we write this out, it's going to be Cu with MnO4 in parentheses and a 2 on the outside. Make sure your subscripts are small. Sub means below, small. It's a lowercase, not lowercase. It's a small number, probably about half size, and it's usually dropped down a little bit. I see lots of really sloppy student handwriting, okay? And I understand that some of you have trouble writing neatly. My children, my boys especially, they can't write neatly to save their lives. But even if you're sloppy, you can make your big letters big and your small letters small. Question?
So that negative side, the MnO, that's the charge for the whole thing? For the MnO?
Yes. The negative charge here, this negative, means this whole ion has an overall -1 charge. That's how the polyatomic ions are. They are a group of atoms bonded together, and overall they have a charge. And so you can't split them up. They're stuck together, super glue. Any other questions? Let's look at the next one. Iron 3 carbonate, iron 3, and carbonate ion. Always look at the charges. Are they the same? 3 and 2. No, they're not. Then you could do the crisscross thing. So if we do the crisscross thing, Fe is going to get a subscript that's equal to the number over here. I'm not going to carry the minus sign down, because that would tell me I have -2 iron atoms. It's like having -2 cars. You can't have minus objects, right? So Fe2, and then this superscript here, the charge 3, will become the subscript over here. This 3 is part of the ion's name. The ion's formula. CO3, and then we're going to put parentheses around it and put the subscript telling us quantity on the outside. If we look at this, we've got 2 times the charge on the iron plus 3 times the charge on the carbonate. That equals 6 minus 6, which equals 0. Any questions? Potassium dichromate. So here's the potassium ion, here's the dichromate ion. What's the formula when those two get together to make a compound? Yeah, we need 2 potassium, so K2, Cr2O7. There's one, oops, 1 plus charge if we're going to do crisscross, which we can because this is 1 and that's 2. They're not the same. That becomes the subscript over here. We didn't write the 1 up there. We don't write the 1 as a subscript either. And this 2 becomes the subscript on the potassium. So we get K2Cr2O7. No parentheses because we only have 1 of the polyatomic ion. Yes? The quizzes and tests you're taking in this class are multiple choice, and I don't believe it's fair to give students like this as one of the incorrect choices. So you won't see that on multiple choice. On the worksheets, if you did that, and if I had time to grade them all, I would just do this. You don't need those. Okay? So not technically wrong, but not right either. Any other questions? If you leave the parentheses out when you need them, then that is wrong, because it indicates something else. Okay?